Hey friends, I'm Shaptarshi. I just completed my Masters in Chemistry from IIT Kanpur. And in this video series for IIT-JAM exam, I wanted to cover all the different types of numerical problems that come for physical chemistry. And by doing those problems, I'll be explaining the concepts as well. In physical chemistry IIT-JAM, 90% of your questions will be numerical based. So it's very important. And just like this video, I'll be making similar videos on different physical chemistry topics as well. So with that, let's get started with this one.
Hello friends, and in the last video we saw the different concepts for solid state and all the important concepts that will be coming in. So if you have not watched that, do watch that, because in this we'll solve all the numerical problems related to all the concepts that we have discussed in the last class. And from these problems we'll cover all the different types of problems that come in the exam. And so having solved these problems, you will be able to solve most of the questions that will be coming. So rather than solving many questions, try to solve different types of questions which I'm bringing out, and try to understand what is happening. Don't just do the problem, but try to analyze what they're asking and what forms the solution is coming in. Right, that will be more helpful rather than doing the same kind of problems again and again. So in this problem we have, let's read the problem line by line. A crystal having simple cubic lattice. So this is our first information, that is a SCC. Has the length of its unit cell A0 picometer. One of its planes shows a first order Bragg reflection at an angle of 60 degree. Taking the wavelength of the X-ray as A0 picometer, find the Miller indices of the plane. So what is our goal? To find the Miller indices. What is a Miller index? I have explained in very good details and examples in the last video. Okay, I'll put this link to the last video in this video as well, so you can check it out. And so let us first write all the information that's given. You see, having a problem that has a lot of very lengthy kind of problem to read, the good thing is most of the information is given. We know it is an SCC, right? First thing, length of unit cell is A0 picometer. If you want, you can pause the video and try it on your own. If you're not comfortable, you can follow it and later you can practice. The length of its unit cell is A0 picometer. So over here we know that the length of the unit cell is denoted by A, as we know, and we know that Bragg reflection is given by n lambda equals to 2d sin theta. I've explained in great details of all these equations, what is glancing angle, what is grazing angle in that video, and also I've explained this important formula where d is equals to A. D is the interplanar distance and A is the edge length of the cell, divided by h square plus k square plus l square, where your h, k, l and l are the Miller indices. So over here the A is given, the length of the unit cell is A0 picometer. So I'm doing nothing but just writing what is given. One of its planes shows a first order Bragg reflection. First order means n is equal to 1, right? At an angle of 60 degree. So this theta is 60 degree, right? Taking the wavelength of the X-ray as A0 picometer. Again, it's A0 picometer. Anyways, so I'm just writing everything that given me. Find the Miller indices. Sorry, A0 picometers. This is also in picometers, right? So what do we have? Let me take another color, and we know n, we know lambda, we don't know d, we know sine theta. We need to find d. If we find d, we know A. H, K, L we need to find. Okay, so you see, from I just wrote down what is given, and from that given I have written two formulas, and when I'm comparing these two sectors, I'm seeing that I can get H, K, L. N is given, lambda is given, sine theta is given, 2 is a constant, d is not given. In the formula of d, if we find d, we can put this value of d over here, and in this we know A, which is A0, and H, K and L we will find. So we have only one unknown variable, H, K and L, and let's see how to do that. Okay, so but that's the good thing, you write everything that's given, write the relevant formulas beside it, and most of your problems will be solved. In my exam I completed, I think except 1 or 2 mistakes, I think I did most of my problems. In organic I left some marks, but in physical and inorganic I got almost full marks. Almost, I made some 1 or 2 mistakes. So a crystal having, so we will do the first part, number 1, number 2. So let's use the formula 1, and over here what is n? N is 1. What is our lambda? Our lambda is A0 picometers. So I'm just writing A0 2 into d sine theta, sine of 60 degree, right? So from this what we can say that d is equals to and sine of 60 degree. So over here let me just write everything, A0 by 2 sine of 60 degree, right? So over here we have this, and now with this information that we have over here, let it remain like this for the moment, and we will input this relation in our second formula. So let me do this. A0, so I'm just using in formula 2 I'm replacing d, so left hand side d is equals to A0 2 sine theta, sine 60 degree, and which is equals to what? A. And what is our a over here? A is our A0, see a mark I'm giving. So this is equals to A0 root of h square plus k square plus l square. Fine. And we all want to do this in the exam, and when we get, rub out the constants. And since okay, let me just go a bit down, and okay, I have my second problem. I'm just putting this a bit down right now so that I can have some space to solve this one. Great. So what we have over here is 2 sine 60 degree is equals to root of h square plus k square plus l square. We can write 4 sine square 60 degree equals to root of, sorry for this will be like root will go off, and we will have our h square plus k square plus l square. So sine 60 degree, if you guys have forgotten the formula, even I forget sometimes, I believe it is root 3 by 2. I really believe this is it. If you forget, use your calculator. Okay, sometimes when you study too much you forget some basics. It's absolutely fine. Don't get discouraged by all these small things that happens. So I just squared this sine 60 degree. So let's see, we have h square plus k square plus l square, and so if we want, we need the value of Miller indices. So we need the value of h, k and l. If that is 1 square plus 1 square plus 1 square, this will get 3. In fact, I think there's only one, it's very simple math. If you see 3 and you have 3 numbers whose square is getting 3, only one number that is going to give, that is 1 1 1. So our Miller indices are 1 1 1, and that is the answer. So yes, so that is how we solve it. It looked tough in the beginning, but as we wrote down the formula, as we wrote down the equations, as we wrote down the given values, it was looking so easy, right? Let us now come to the second problem. Okay, so this is the previous one was a very important one regarding Bragg's equation, because Bragg's equation is very asked in the exam. Okay, let us now come to this one. Again, same policy, nothing different. Smallest observed Bragg diffraction, angle of reflection from 1 1 1 plane. First information. So let us just write all the given things first. Given, use your rough pad well, write all the given things over there. So what is given is that 1 1 1. So our Miller index is HKL, that is 1 1 1. Done. Potassium crystal is theta 6.613 degree. So theta is our 6.613 degree, and X radiation of wavelength lambda equals to 70.926 picometer is used, given that potassium exists in a body centered cubic lattice. Okay, so body centered cubic. So over here, whenever anything comes now like SCC, VCC, FCC, only difference is the value of Z that comes in the density. In BCC, if you know, the value of Z was 2. In SCC it was 1. In FCC it was 4. You guys know this, I know. Determine the length of the unit cell. Length of unit cell means A is the question, and density. So density, let me just write density question mark. So these two things we need to. So this is a very typical problem that might be asked in your NAT problem for 2 marks, and if you know it, you get your 2 marks, and you might go from getting like 700 rank to getting lower than 500 or lower than 400 as well. 2 marks is very important in the exam. So the why is it a typical problem? Because they're using back diffraction to find the density. Remember in the previous video when we were discussing about the problems, we discussed 2 main equations. One was Bragg and one was your density formula. This is a problem where they're combining both of them and asking a question. That's why I have very selected pick. That's why I'm telling, like, understand what is going in the problem rather than doing too many problems. Understand what's going in the problem and solve the different types of problems rather than doing too many problems. So let us read the question again. Smallest observed Bragg diffraction angle of reflection from 111 HKL is this. Potassium crystal is theta when X-ray radiation of wavelength lambda is used. Okay, till now, because how can we read 2 sentences and understand what's going on? Let us read 1 sentence and understand what's going on. What is Bragg reflection formula? N lambda 2D sine theta. Okay, so over here, so they have not given the order of reflection. When they do not give the order of reflection, angle of reflection, normally we take it as 1. Okay, when they do not give, we take it as 1. Lambda is given, it is given. D is given. So A we do not know, HKL we know. So D is question mark, and sine theta, theta is given. So from this again we need to find D. And so that is one formula. And what is the second formula? Given potassium, last line we are reading, given potassium exists in body centered cubic lattice, determine the length of the unit cell. So A, right? And what is the other formula that we will be using over here? So we know that our D is equals to AA divided by H square plus K square plus L square. And what is our density formula? Density is, let me write, rho is equals to your mass by volume, right? So even I sometimes don't remember the formulas, but I know it's mass by volume. And in the last video I explained beautifully how it was, you can mentally derive it. It is so easy to derive. So this is nothing but your mass by volume, and for that you need to like have this Z, that is the number of atoms. For that particular BCC it will be 2, and your atomic mass, your Avogadro number, and your volume, which is A cube, right? In the last video you can see, if you are not understanding it, I explained very easily and beautifully how this was derived. Okay, so over here to find density we need A. We know mass is given, Z we know, Avogadro number we know. So we need A, and how will we get A? And do we know D? So even if we do not know D, we can just replace that, this, let me use this color to understand what I'm trying to do. I can just replace this formula only in our Bragg's equation, and then from here we can get to know A. And if we know A, we can put it here, and then we can know density. You see the same thing I used in the last problem and this problem. I wrote the given things, I wrote the relative formulas, I correlated one with the other, and I found out what is unknown, and that was the question itself, right? Do it systematically, methodically. You will not, because why will you make mistakes? In organic you can make mistakes. I mean, reactions are so unpredictable, and they will always ask the special case or the exception case, right? There you can make mistakes. In physical, if you know the concept, no room of mistakes. Silly mistakes might happen, that's human, but on normal level you should not. Where is this? Sorry for that. Let me. So now what I'll do, I'll just replace all of your values. As simple as that, nothing. So what is lambda? 70.926 picometers. So I'm just, this is suppose 1 Bragg equation. I'm just replacing this 1. What is 1? 1 lambda is my 70.926 picometer. 2 D, we will replace this formula, that is A root of HKL. We will replace HKL by what? As it is given. So what was given? Let me see HKL values. 1, 1, 1. So we will replace that over here. 1 square plus 1 square plus 1 square into sine theta. And what is this theta value? We have 6.613 degrees. where is my pen? Sine of 6.613 degrees. Okay, so this value you have to find your calculator. You do not say that. So over here we can find A. Simple as that, we can find A, and it will be, we'll get in picometers. So again, so if we find A, I'll just look it up what it happens. So the value of A that comes around is around 5.335 Armstrong. Okay, you guys can do it and check, because I won't want to waste your time. It's simple calculation, you guys can do it easily. So this is an Armstrong, remember this, picometers and Armstrong. So they have given the value in Armstrong. It depends on what is asked. So remember the units very well. Your Armstrong, as far as remember, this is 10 to the power minus 10 meters. Picometer is 10 to the power minus 12 meters, right? So you see what is asked. If nothing is asked in NAT, they might give the actually the units they wanted. Be very careful of these things. These are the places you will make mistakes, not in the systematic way, right? You might make silly mistakes, try not to do it, be careful. And so we found out A. We need to find your density. So that is also very simple, because we already know that it is. So we come, let us say this is 2. So we know from 2 we can say our density we need to find. Z is 2 because it is BCC. Our M, I'll just check what it is, and N is 6 into the power 10 to the power 23. A cube 5.335 whole cube, and our your M was, what was M? 39. Great. So 39, and if you do this, you will get the answer as your, so again like you have to do the whole thing and you have to see it for yourself, but the value you can just check it, and by doing it you can just check what will happen. The value that they have given is 0.854 gram per centimeter cube. So they have converted this, this was in Armstrong, they have converted this by 10 to the power minus 8. Okay, if you want to convert to centimeters, it will be minus 8, and you have to do that. So people normally, when also remember that people actually get stuck in the lengthy calculations, they give up in between. Please don't give up in between, because you're just 1 or 2 steps away from your answer. Okay, because the main thing you have done, you have to just convert the units and see what you have to do. And your what mass was in gram per mole, and this was also like Avogadro's number unit is in per mole. So this gets cut and you will get gram per centimeter cube, right? So guys, if you have any problem, still not understanding, watch the video again. If you're still not understanding, please go visit my video that I have made. I've explained only the most important concepts that you should revise in the last moment, that will come in the, that has a high chance of coming in the exam. Okay, so those were the main 2 typical problems that could come. Another problem or a trick I want to tell you, because it is so easy, I don't want to miss you, I don't want you guys to miss out on this, is that suppose they give a plane, they give the Miller indices, right? They will tell indices, they will tell this is given, they will tell, say it is SCC, it is BCC, or it is FCC. I don't know whether you guys know this trick or not, but there's a beautiful trick to this, is that if it is SCC, it is valid for all H, K, L values. If it is BCC, then what is the condition is that H plus K plus L, this has to be even. If it is FCC, what the case is that H, K, L, this should be all odd or all even. So suppose they give you a plane like your 110 example, they give this plane 110, right? You have to say this is SCC, BCC or FCC. Answer is SCC will be there because it is valid for all HKL values. Second is for BCC, what it's the case that all the H plus K plus L has to be even. So 1 plus 1, 2, that is true. So it will be BCC. FCC, it has to be all even or all odd. So that is not true because there is 0 and 1, right? So it is not all odd or all even. So this is not FCC. And over here I'll just give some more examples of this, that 1 1 1, and so this will be SCC will obviously be there, BCC, so it is the H plus K plus L value has to be even, otherwise the BCC cannot hold, so it won't be BCC. But for FCC should be all odd or all even, and this is all odd, so FCC will be valid. So with that we have covered all the different types of problems. If you want to practice more problems, you have free time, do it, but more than that I will tell you, try to analyze the problems, think in your head what is going on, try to see the different types. This is the main glitch, because if you want different, more and more, that will never end. You should obviously do more problems for your practice, but this is the main thing, the different types of problems that can come, and do that. Okay guys, so that with that I will leave you, and if you have this video helped you, you can put some comment so that I can also be encouraged to put some more videos. I will be putting more videos on different physical chemistry topics in the coming days. Almost every day I'll putting videos right now, because the exam is very nearby and you guys should practice as much as possible. And all the best, and whatever happens, study till the end, don't give up right now, because exam is at hand and you never know, a good rank can truly actually change your life. God bless you guys and all the best.